So continuing on our conversation about reference types and value types, I would like to talk about structs versus classes. So we've already found out that classes are reference types. And now there's a new concept that will be introduced to you, which is called structs. Structs are actually pretty similar visually to classes, and that's why it can get a bit confusing, because structs are actually value types. So remember our previous example where we had a person custom type and we gave it a first name, last name, then changed it and got back the changed first name and last name, right? And the point of that was that whenever we get to change name, we're actually getting the pointer. So we're actually changing the same object that this person has created. So this person and person to change right here are pointing to the same object. So when this comes back, right, so when change name gets popped off the stack and we get back to the main method, the first name and the last name are actually the ones that have been changed in the change method. And we can do that one more time just to verify that that still works, right? If it didn't work, I would actually be very surprised, but let's give it a shot and see if it in fact changes it to Jane Doe. And that it does, Jane Doe. Now, let me go back to my custom type, open it up, and change this into a struct. So first of all, structs are basically used to group related variables together. That's all it is. They are pretty similar to classes, but only visually, right? And some major differences are that, first of all, structs are value types. Also, they're a lot more basic, meaning structs cannot have inheritance. So one struct cannot inherit from another one, but classes can. So classes are more advanced, and structs are basically just a way for us to group variables together and pass them on, right? And they're value types. So they're only similar visually. That's why this can get confusing, and you'll see why in a second. So I changed person to a struct now. Now let's go back and, everything else looks the same, right? We pass it on to this method. We change the first name and the last name. We get back. What do you expect the first name and the last name to be? Is it also going to be Jane Doe like the previous example, or is it going to stay as John Smith? Let's give it a shot. So we see that it's John Smith. And the reason why is because it is a value type. So let's look at a diagram. So here we have our main and change name methods that have been pushed onto the stack. First, main has been pushed, and main had the person struct. But here's the interesting part. Do you remember the previous example where the person custom type has been saved on the heap? In this case, it's saved on the stack. Why? Well, if you remember, all our value types are saved on the stack, not on the heap. And that's really what's happening here. In main has its own value type person, which was a struct. And then change person, when from main we go to change name, even though we pass in this person to change name and we change it to Jane Doe, the moment change name gets popped off the stack, what happens is this. Now we're left with the original John Smith person, which was the struct that we created in the main. But the other struct has been gone from the stack. It has been popped off the stack. So we have our original copy, but the changed copy has been gone. And once again, the reason why I want to stress this out is because just for the reason that structs look similar to classes, people might confuse them and expect behaviors from structs that are incorrect, because they expect a behavior from a struct that they would expect from a class. But that is only if you don't know the difference between value types and reference types. But now you do, and so you won't confuse them anymore.